Good evening guys. For today's video, we will now going to summarize all the topics in chapter 1 to chapter 11. We now stand at a critical turning point in the use of technology to extend and empower our ability to communicate. The globalization of the internet has succeeded faster than anyone could have imagined. The manner in which social, commercial, political, and personal interactions occur is rapidly changing to keep up with the evolution of this global network. In the next stage of our development, innovators will use the internet as a starting point for their efforts, creating new products and services specifically designed to take advantage of the network capabilities. As developers push the limits of what is possible, the capabilities of the interconnected networks that form the internet will play an increasing role in the success of these projects. So, networks and the internet have changed the way we communicate, learn, work, and even play. Networks come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of networks. The internet provides the services that enable us to connect and communicate with our families, friends, work, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur, and it is made up of network components including end devices, intermediate devices, and network media. Next, networks must be reliable. This means that network must be fault tolerant, scalable, provide quality of service, and ensure security of the information and resources on the network. The network infrastructure can vary greatly in terms of size, number of users, and the number and types of services that are supported. The network infrastructure must grow and adjust to support the way the network is used, and the routing and switching platform is the foundation of any network infrastructure. Every computer requires an operating system to function, including computer-based network devices such as switches, routers, access points, and firewalls. These network devices use an operating system called a network operating system. A network operating system enables device hardware to function and provides an interface for users to interact. In the CCNA course of study, students learn to configure both devices that connect to the network and devices such as PCs and devices that connect networks together, intermediary devices like routers and switches. Learning to configure the Cisco Internetwork Operating System, Cisco IOS on Cisco routers and switches is a large part of the Cisco CCNA program of study. The Cisco Internetwork Operating System, or the IOS, is a generic term for the collection of network operating systems used by Cisco networking devices. Cisco IOS is used for most Cisco devices regardless of the type or size. Cisco IOS is a term that encompasses a number of different operating systems which runs on various networking devices. Then the technician can enter commands to configure or program the device to perform various networking functions. Cisco IOS routers and switches perform functions that network professionals depend upon to make their network operate as expected. Cisco iOS routers and switches support a similar model operating system, support similar command structures, and support many of the same commands. In addition, both devices have identical initial configuration steps when implementing them in a network. Rather than developing unique and separate systems for the delivery of each new service, the network industry as a whole has adopted a developmental framework that allows designers to understand current network platforms and maintain them. At the same time, this framework is used to facilitate the development of new technologies to support future communications needs and technology enhancements. Central to this developmental framework is the use of generally accepted models that describe network rules and functions. So data networks are system of end devices, intermediary devices, and the media connecting them. For communication to occur, these devices must know how to communicate. These devices must comply with communication rules and protocols. TCP or the IP is an example of protocol suite. Most protocols are created by a standard organization such as the IETF or IEEE. The Institute of Electrical and Electronics Engineers is a professional organization for those in the electrical engineering and electronics fields. The most widely used networking models are the OSI and TCP or IP models, associating the protocols that set the rules of data communications with the different layers of these models is useful in determining which devices and services are applied at specific points as data passes across LANs and WANs. So wireless media carry electromagnetic signals that represent the binary digits of data communications using radio or microwave frequencies. The number of wireless enabled devices continues to increase. For this reason, wireless has become the medium of choice for home networks and is quickly gaining in popularity in enterprise networks. All data link layer protocols encapsulate the layer 3 PDU within the data field of the frame. However, the structure of the frame and the fields contained in the header and trailer vary according to the protocol. Because the Ethernet is comprised of standards of these lower layers, it may best be understood to reference to the OSI model. Then the OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. At the data link layer, the frame structure is nearly identical for all bandwidths of Ethernet, and the Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. There are two styles of Ethernet framing. The IEEE 802.3 Ethernet standard and the DIX Ethernet standard, which is now referred to Ethernet 2. So the layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. The network layer 3 or OSI layer 3 provides services to allow end devices to exchange data across the network. In addition to hierarchical addressing, the network layer is also responsible for routing. In order for routers to be reachable, the router interface must be configured to enable a specific interface. Enter interface configuration mode using the interface global configuration mode command. The applications are computer programs which the user interacts and which initiate the data transfer process at the user request. All these elements work together at the application layer, then the application layer enable users to work and play over the internet. Now we're done summarizing all the topics in chapter 1 to 11.